Okay, so last class we already studied about interference of water wave. Okay, let me go through with the interference of light wave. Okay, kalau kita nak buat diffraction, kita guna single slit. Single slit, must remember. When we do the diffraction part, or diffraction of light wave, okay, kita akan gunakan single slit. Nampak? Single slit. Kalau kita nak buat interference, kena ada double slit. Sebab kita nak dua wave itu overlap. We want the two wave to be overlap. Jadi kita kena letak double slit lah. Okay? Double slit, kita panggil eksperimen ni sebagai Young's double slit experiment. Sebab yang ini eksperimen ni dijalankan oleh Young. Young ni seorang physicist lah. Dia ada Young double slit experiment, dia ada juga Young modulus, macam-macam ada atas nama dia. Okay, baik. So the light source must be monochromatic. Light yang kita panggil mesti dia, it must be in monochromatic. Monochromatic means it contain only one color, one wavelength only. Okay, we cannot have multiple colors. Then you cannot see the interference pattern clearly. Okay, and then you put the double slit, then you put monochromatic lights, fix a certain distance so that your it can form the pattern on the screen. The pattern that form on the screen as shown, you will get series of dark and bright fringes. Okay, yang ni kita panggil dark and bright fringes lah. Okay, yang dark fringe tu maksudnya destructive interference. Yang bright tu adalah constructive interference. Kalau question dia tanya, why there is a dark and bright fringes? Kamu cakap, dark fringes is formed due to destructive interference, while bright fringe formed due to the constructive interference. Okay, baik. The double slit must be very narrow, about 0.5 mm, to produce a clear interference pattern, because wavelength of light is very small, very hard to show. Jadi kamu punya slit betul-betul kena sempit. It's about 0.5 mm. Okay, so when the light from the monochromatic source pass through the double slit, two source of coherent lights are produced. Because yang ni pun, sebab yang ni pun dia akan menghasilkan cahaya. Yang ni wave, light wave. This one also light wave. So they overlap and produce interference pattern. So jadi double slit ni berfungsi sebagai coherent source. Okay. The interference patterns produced consist of bright fringe and dark fringe, which is alternately produced lah. Okay, baik, ni contoh dia. Jadi jarak antara dua double slit, the slit is the coherent source. So jarak di antara jarak di antara dua slit tu maksudnya slit tu yang menghasilkan coherent source. Jadi jarak antara dua coherent source ialah apa? Itu kita panggil A. Distance between the two slits on the double slit plate. Okay. And then X is what? Distance between two consecutive bright or dark region. Contoh, bright to bright or dark to dark, also known as X. And the D is distance between A and X lah. Distance between the double slit plate and also the screen. Kita ada wavelength. Wavelength tu lambda lah. Yang ni untuk kita kira lah. Lambda equal to AX over D. Okay. Problem is they will give everything, all these things in a wording. So you need to put in correct. You must know. Once you read the description, I know this is A, this is X, this is D. And make sure you convert them into SI unit, only meter. That would be good lah to answer. Right. Constructive interference. Constructive interference happen when two crest or two trough meet when propagate. The bright fringe are region called the antinodes where the constructive interference occur. Okay. While destructive interference happen when a crest meet to and a trough meet when propagate, the dark fringe are the nodes where the destructive interference occur. As I told you, bright fringe representing constructive, dark fringe representing destructive. Okay, now how wavelength affecting interference of water wave? Water wave tu tukar jadi light wave. Tu saya silap type. Jadi bolehkah kita control wavelength? Boleh, sebab we got 7 colors, right? Merah jingga, Michael Jackson kena halau balik India Utara. Okay, kita kena tahu the wavelength series, light spectrum. Michael Jackson kena halau balik India Utara. Merah, jingga, kuning, hijau, biru, indigo, ungu. Jadi merah ni wavelength dia okay, macam mana kita nak compare wavelength bagi red color is greater than the wavelength bagi the blue color. Normally we compare red and blue. Yang ada kat atas tu ada wavelength yang sangat panjang lah. Okay, jadi kita buat macam ni. We take a lamp, we put a color filter. Kita boleh filter color dia. Okay, first you put red filter. Your lamp is switched on and then you observe the interference pattern. Okay, and then measure the distance across 11 consecutive bright fringe. Nanti kita akan bahagilah. Lepas tu kita ganti dengan blue filter and then yellow filter. Okay, kamu tengok. Red color filter interference pattern dia macam ni. Yellow dia jadi macam ni. Blue dia jadi macam ni. Red wavelength dia panjang. Jadi X dia pun panjang. Yellow is moderate. Jadi X dia pun moderate. Blue wavelength dia pendek, maka dia punya X pun pendek. So we know, right, lambda is equal to AX over D. Okay, kita nak compare apa? X dengan lambda kan? Jadi bawa dia orang sama-sama. Kita akan jadi A and D, right? Hubungan dia bahagi. Membawa maksud, when the wavelength is greater, your X will be greater. Okay? So that's the interpretation. Okay. So an increase in the wavelength of monochromatic light source result in increase in the distance between two consecutive bright fringe or X. They just put it in a long sentence. Because your distance between two consecutive bright fringe is directly proportional to the wavelength. Okay? Ingat yang ni. Red, orange, yellow, green, blue, indigo, violet. Okay? Longest wavelength is red. Shortest is the violet. Okay, dari kiri pergi ke kanan, wavelength semakin menurun. Okay, decrease. Right. What are the common error here? Let's see. Common error dia, cara kita kira. Okay. Dia cakap, the distance across 6 consecutive bright fringe is 12 mm. Dia akan buat 1, 2, 3, 4, 5, 6. Okay. Kalau lepas tu dia akan bahagi dengan 6. Okay. Sebab kita nak kira apa? Kita nak kira X lah kan. Okay. So sekarang kita ada dia tengok. Dia baca saja 6 consecutive bright fringe is 12 mm. Maksudnya dia akan baca macam ni. Consecutive bright fringe tu 6x adalah 12 mm. Jadi X dia adalah 12 divide 6, which is equal to 2 mm. This is wrong. Bukan macam tu. Kalau dia cakap 6, tengok dulu diagram kamu. 6, sebab kita punya X ni jarak di antara 2 tau. Not, if there is a 6, that you divide 6, cannot. See, 1, 2, 3, 4, 5, 6, you label like that. Then, you measure ada berapa X. 1X. 2x, 3x, 4x, 5x. Jadi 12 divided, maksudnya walaupun dia cakap 6 consecutive dry fringe, that means 5x only you can form is equal to 12 mm. Jadi x-nya adalah 12 over 5, 2.4 mm. Okay, right. Can understand, Safrina, son?
Can, sir.
Can, huh? Okay, now I want you to try out the calculation. Okay, I give you a few calculation. Do it carefully. I want you to try all the four lah. Okay. Jadi kita tengok yang ni. Okay, what answer you get first? You let me know that. What answer is that?
5 times 10 power of negative 6 mm.
Mm.
Hmm.
Oh, tak boleh. Kena bagi semua jawapan dalam meter sahaja. Tadi cakap kan semua dalam SI unit. Okay, that's
நான்லாமே mmல செஞ்சேன்.
mm lah செய்யக்கூடாது, meter மாற்றணும். Kalau boleh lah. Sebab option lah வந்து meter jawapan தான் கொடுப்பாங்க. Okay. A monochromatic light source with wavelength 600 nanometer. So lambda is equal to 600 nano na 10 to the power of negative 9. Is used in the Young doubles experiment. A series of interference fringe is produced on a screen placed at 2.5 meter. See, a series of interference fringe is produced on the screen placed at the distance from double slit. Jadi jarak antara screen dengan double slit is D, which is equal to 2.5 meter. What is the distance between the double slit? Distance between the double slit. Double slit adalah coherent source. Jadi distance between coherent source adalah A, berapa? If the distance between two consecutive dark fringe, dark, bright, dark. Distance between two consecutive dark fringe means your x. Your x is equal to 1.2 times 10 to the power of negative 3. Milli tu negative 3. Dah tukar macam ni, baru kita apply kita punya formula. Lambda is equal to AX over D. Tapi sekarang dia tanya apa? A kan? Jadi susun balik equation. Lambda D over X is equal to A. Okay. Sekarang kita ganti. Lambda வந்து 660 times 10 to the power of negative 9. You multiply with D, which is 2.5 meter. Kalau semua dalam meter, senanglah untuk kita kira. Jawapan pun dalam meter. Okay, yang ni 1.2 times 10 to the power of negative 3. Jadi, apa jawapan yang kita dapat? Kita tengok. Kalau kita ni calculate pen apa?
1.25 times 10 power of negative 3.
Uh, 1.375, right? No,
And 1.25
wait, 660 power negative 9, 2.5 kilo 1.2 power negative 3 தானே?
Yeah, 600.
600. Oh, 600. 600.
நானும் தப்பா
போட்டுட்டியா? Sila tengok ni. Betul. 1.25 times 10 to the power of negative 3 meter. Kalau nak sebut dalam millimeter pun, in the negative 3, tukar jadi milli. Betul tak? Apa? Itu millimeter ke mata porena 1.25 times millimeter. அவ்வளவுதான் வரும். ஏன்னா மில்லியோட அர்த்தம் 10 power negative 3. Ganti je lah. Tapi tidak digalakkan untuk membuat demikian. Jadi jawapan ini sudah memadai. Okay, moving on to the next question. So ada yang suka banyak tanya tentang apa ni? Interference of light. In Young double slit experiment, the distance between double slit and the screen, maksudnya D, antara double slit dengan screen is 4 meter. The separation of the two slit. Separation maksudnya distance between. Separation tu distance between maksudnya. So the distance between two slit is A, which is 0.5 times 10 to the power of negative 3. Sebab ada milli. Sekarang dia tanya, dia bagi D, dia bagi A. Kalau question A, dia tanya if violet light with this wavelength, what is the distance between two consecutive bright fringe? X dia berapa? Lambda diberikan mengikut soalan dia lah. Jadi, we know that lambda equal to AX over D. Sekarang kita nak cari X. Jadi, lambda D over A equal to X. Okay, kita derive the formula already. Now, we answer the question. For question A, lambda is 4 times 10 to the power of negative 7. Your D is 4. Your A is 0.5 times 10 to the power of negative 3. Okay, berapa kamu punya X? And then for B, just ubah dia punya wavelength saja. 7 times 10 to the power of negative 7 multiplied by 4 divided by 0.5 times 10 to the power of negative 3. First one,
3.2 times 10 power of negative 3.
3.2 times 10 to the power of negative 3 meter. Okay. The second one,
5.6 times 10 power of negative 3.
di sini kamu boleh nampak. Kalau wavelength dia lebih panjang, dia punya X lebih panjang. Kalau wavelength dia pendek, dia punya X pun pendek. Okay, next one. Kalau dia kadang-kadang dia akan bagi soalan macam ni pula. The wavelength of light can be determined with a double slit plate. The diagram below shows the patterns of interference fringe obtained from Young double slit experiment. The separation of the two slit. Separation maksudnya distance between two slit. Okay, is equal to 0.4 times 10 to the power of negative 3. The distance between screen and the double slit. Maksudnya D kamu adalah 3 meter. Kita nak cari wavelength. Sebelum tu kena cari X. X ni berapa X ni? Kita kena cari dulu. 1X, 2X, 3X, 4X, 5X, 6X, 7X. 7X adalah 35 mm. Jadi X adalah 5 mm. 5 mm tu 5 times 10 to the power of negative 3 meter. Sekarang kita kira lah lambda tu berapa. Lambda tu adalah AX over D. A dia adalah 0.4 times 10 to the power of negative 3. X-nya adalah 5 times 10 to the power of negative 3. And D dia adalah, apa benda tu? 3 meter. Berapa jawapan?
7.5.
No. 0.4 power negative 3. 5 power negative 3. Divide 3.
6.67 times 10 negative 7.
6.67 times 10 to the power of negative 7 meter. Jangan lupa. Okay, right. Kita pergi yang seterusnya. In an experiment of light interference using green light of wavelength, in an experiment of light interference using green light of wavelength 5 power negative 7 meter. Okay, wavelength dia dah bagi. Two consecutive, okay, saya tulis dulu. Wavelength dia adalah 5 times 10 to the power of negative 7 meter. Two consecutive bright fringes are formed on the screen that are 0.4 millimeter apart. Two consecutive bright fringe. Okay, that means your X 0.4 millimeters times 10 to the power of negative 3 meter. When the experiment is repeated using monochromatic light L. Okay. Yang ni kalau kita gunakan green color lah. Green color light. Okay, sekarang kita gunakan dia repeat the experiment using monochromatic light L. Light L பாய்க்கிறாங்க. So the consecutive bright fringe formed are 0.48 millimeter apart. That means X வந்து 0.48 கிடைக்குது. அப்படி light L பாய்ச்சா. அப்ப இதோட wavelength எவ்வளவு அப்படின்னு கேட்குறாங்க. So அப்படின்னா என்ன அர்த்தம்னா, okay, kamu tengok ada dua case kan dekat sini. அப்ப இதுல வந்து நம்ம lambdaவும் Xம் மாறுது. X1 lambda 1. Sorry, X2 lambda 2. Okay, kamu tengok. Lambda 1 is equal to AX over D. Okay, so lambda 1 over X1 equal to A over D. Okay. Dia cakap dia hanya tukar light saja. A dengan D tak ada berubah kan? Betul tak? Faham tak?
Ya.
Okay, untuk light L sama juga, dia akan jadi lambda 2 X2. Tapi A dengan D tak akan berubah. Sebab dua-dua pun equal to A dengan D, jadi kita bolehlah form equation lambda over X1 equal to A over D, and A over D also equal to lambda 2 over X2. Buat proportion saja, lagi senang. Ada setengah orang dia akan cari A dengan D, tapi tak boleh sebab apa tak boleh? Sebab kalau dia satu unknown saja memang boleh, tapi dia A dengan D ada dua unknown. Jadi dia memang tak boleh cari A dengan D separately. You need to think in this way. Okay? Dia ubah lambda dengan X saja. Sebab tu kita ada lambda 1, lambda 2. X1, X2. A dengan D dia tak berubah. Jadi dia A dengan D constant saja. Jadi kita like equation 1, equation 2 lah. In other words, it's a simultaneous equation. Okay? Baik, lambda 1, 5 times 10 to the power of negative 7. X1, 0.4 times 10 to the power of negative 3. Equal to lambda 2, 0.48 times 10 to the power of negative 3. Yang tu X, sorry. Over lambda 2. What is your lambda 2? Lambda 2 is equal to 5 times 10 to the power of negative 7. Kamu darab dengan 0.48 times 10 to the power of negative 3. Lepas tu bahagi dengan 0.4 times 10 to the power of negative 3. Berapa lambda 2 kamu?
6 times 10 negative 7.
6 times 10 power negative 7 meter. Okay, kejap. Let me check. Yes, 6 times 10 to the power of negative 7 meter. So, setiap soalan tu ada dia berbeza-beza sikit lah. Jadi, ni contoh-contoh soalan yang dia boleh tanya. Can understand interference of light?
Can, sir.
Okay, come. We go to interference of sound wave pula. Interference of sound wave macam mana kita buat? Okey, kita akan tengok. Calculation dia tak banyak pun. Okey. Baik, kita tengok. Interference of sound wave. Interference of sound wave, kita kena ada satu audio signal generator. Okey, dalam audio signal generator ni, okey, kita mesti kena ada dua loudspeaker. Yang itulah A dia. Okey, lepas tu bagi satu orang jalan along the straight line path. Di situ dia akan ambil konstruktif dia adalah loud sound, destruktif dia adalah soft sound. Jadi dia akan dengar loud sound, soft sound, loud sound, soft sound, loud sound, soft sound. So the distance between two consecutive loud or two consecutive soft sound is the X. And the distance between A and your X taken is D. Okay. The apparatus as shown in the figure above is set up on a table located on an open space such as assembly area like that. Okay. Or laboratory building to avoid disturbance by reflected wave. So this is the precaution you should take. Okay, when conducting this experiment, make sure it's an open space. We don't want any echoing. Interference of sound wave when two loudspeaker are connected to the same audio signal generator. Maka dia akan terhasil dua wave yang sama jenis lah, sama phase, in phase lah. Okay, not to say in phase, they have the constant phase difference. This is to produce coherent sound wave. They want to produce the same type of sound wave. Okay, using the meter rule, the distance between the loudspeaker A is fixed at 1 meter. The audio signal generator is switched and its frequency is adjusted to certain level. Okay, why they adjust frequency? Kenapa frequency datang? Okay, kita tahu V equal to F lambda kan? Kita control lambda melalui frequency. Okay, so to adjust the wavelength of sound. Kalau kamu rendahkan frekuensi, wavelength dia jadi panjang. Kalau kamu tinggikan frekuensi, wavelength dia jadi pendek. A student or observer is requested to walk along the straight path at distance 2 meter from the loudspeaker. The student can hear loud and soft sound alternating, okay, as you walk along the straight path. Okay, so maksudnya A kamu di sini adalah distance between two loudspeaker. X kamu adalah distance between two consecutive loud sound or soft sound. Jarak antara A dengan X adalah D. Okay, distance between loudspeaker and the path along which interference can be detected. Lambda is wavelength of sound wave lah. Okay. Right, constructive. How you differentiate constructive and destructive? Constructive is where you can hear the loud sound. Destructive is where you can hear the soft sound. Okay. Baik, kita cuba buat calculation ni. Okay, cuba buat dulu. I want you to try first. Remember, you have frequency V equal to F lambda maybe come into handy. Okay, jom bincang. In an experiment of the interference of sound wave, the two loudspeakers are placed at a distance 1.5 meter each other to D. They are connected to an audio signal generator to produce coherent source at frequency 0.5 kHz. Calculate the wavelength first. Okay, so V equal to F lambda. Dia bagi speed dah. Jadi kita nak cari apa? Wavelength. Okay, wavelength adalah V over F. Jadi lambda is equal to V 300 over frequency 0.5 kilo tu tukar jadi power 3. Which you get?
6 times 10 power of 5.
Buat lagi sekali. Tak mungkin jawapan tu.
0.6.
0.6 meter. Sound wave ni panjang, jadi dia kita belajar kan masa diffraction. The wavelength of sound wave is more than the wavelength of light wave. Yang light wave tu yang ada negative 7 macam tu semua. Kalau sound wave dia lebih kurang macam 0.6, 1 meter, 0.2 macam tu je. Okay, the distance between the two consecutive soft sound at a perpendicular distance of 5 meter from the tadi saya cakap silap. Yang tu bukan D. Yang tu distance between two loudspeaker is A. Sekarang dia tanya distance between two consecutive soft sound X. Okay. That a perpendicular distance of 5 meter from the source of the sound. Maksudnya di sini A kamu, di sini X kamu diambil, jarak perpendicular dia adalah 5 meter. Maksudnya that is your D. Okay, so we know that A is equal to 1.5 meter, D is equal to 5 meter, lambda dah dapat 0.6 meter. Sekarang kita kena cari X je lah. X equal to how much? So, lambda is equal to AX over D. Jadikan X sebagai subjek, lambda D over A. Ganti, lambda dia adalah 0.6, D dia adalah 5, A dia adalah 1.5 meter. Jawapan? 2 meter. Using the concept of wave interference and other appropriate physics concept, explain how the distance between two consecutive loud noise is reduced if the experiment is carried out at night. Macam mana kita nak kurangkan distance between two consecutive loud noise? At night, what will happen? Or what you should do? Explain how the distance. Dia tanya not what to do lah. Explain how the distance is reduced if the experiment is carried out at night. Kena relate with your refraction lah. At night, sound travel how? Ingat lagi? Night tu density dia macam mana? Kena ingat yang tu semua. Okay, but I just recall for you. Where is your 5.4? Missing saja. Kejap. Yeah, 5.4 notes. Kena tahu relate dengan yang mana. Okay. There. Can you see? At night, cool air. So the speed of the sound is slower. Correct or not? See here. Syuta pula. Safrina, boleh nampak?
Boleh.
Kalau warmer air, dia faster speed. Sebab warmer air, particle semua faster. So, dia punya sound of the speed is faster. Kalau cool air, relax je lah dia jalan. Okay. Kalau dia tiba-tiba kenapa? Apa kena mengena dengan night? Kena fikir dulu. Soalan fizik memang macam tu. Okay. Right. So, kita kena explain. At night, Okay, at night. Uh, the air is cooler and denser. So the speed of the sound is slower. Okay, kalau speed dia kurang, relate V dengan lambda. Okay, so kalau speed dia kurang, lambda pun akan kurang. Okay, directly proportional. Lepas tu lambda equal to AX over D. Kita compare lambda dengan X. Okay, so oleh sebab V directly proportional with the lambda, so apabila V kurang, lambda kurang. Manakala lambda pula directly proportional dengan X, jadi kalau lambda kurang, X pun akan kurang. Faham tak idea dia?
Faham.
Kena relate macam ni. So the speed of the sound is slower. So the speed of sound directly proportional to wavelength. So the wavelength decreases. Since wavelength of sound wave directly proportional to distance between two consecutive loud sound, okay, since wavelength of sound wave directly proportional to the distance between two consecutive loud sound, the distance is also decreasing.
Okay, done, sir.
Done, okay, next one. Next one, we compare all the three interference wave phenomena together lah. You can see everything at here. So untuk water wave punya eksperimen, kita akan tengok dia punya X dia adalah distance between two consecutive antinodal or nodal line. Okay, antinodal adalah konstruktif dan nodal adalah destruktif. Untuk sound wave punya eksperimen, konstruktif dia adalah loud sound, destruktif dia adalah soft sound. Okay. Untuk light wave, bright fringe adalah konstruktif, dark fringe adalah destruktif. Tengok dia kena diffract dulu tengok betul-betul. Dia tak terus pancar macam tu dia kena diffract dulu guna single slit. Lepas tu baru guna double slit, baru dapat interference pattern macam ni. Okay. Baik. Here the wavelength of water is influenced by the frequency of vibrator. Here the sound wave also, the wavelength of sound wave is influenced by the frequency. Tadi saya dah cakap adjust you punya frequency. Here the wavelength is depends on the color you use. The others all you know lah. Okay, right. Some of the application of interference of wave in daily life. Contoh, bulbous bow, this one, this part, generate water wave which interferes destructively with the wave around hull. Creates calmer water around the ship, less water drag. Okay, jadi yang bahagian bawah tu itu kita panggil apa ni, bulbous bow ni, okay, dia akan hasilkan, it try to make destructive interference. Kalau destructive maksudnya normal water wave dia ada, yang ni dia cuba make destructive interference. Maksudnya dia punya ombak tak tinggi, water dia tenang, lepas tu rintangan air pun dia kurang. Ni contoh dia. Contoh, we apply the destructive interference in the water wave. Okay, kalau sound wave sound wave kita ada ni noise cancellation. Okay, kejap. Yang ni. Dalam light wave pun dia ada anti-reflection lens has coating that cause reflected light to have destructive interference. Yang ni susah sikit nak explain. Ni kena panggil pakar mata baru boleh explain lah. Okay. Tapi kalau kita buat spek kan, dia akan tanya nak reflection ke tak nak reflection. Kalau cakap anti-reflection, dia akan cakap, oh maksudnya multi-coating lah. Dia akan cakap perkataan multi-coat. Multi-coat ni dia akan coating satu layer ke atas. Okay. Untuk apa kita tak nak berlakunya destructive interference? That means too bright. So it will be like a calm only. So this improve the vision. Untuk noise cancelling headphone, kita ada noise cancelling headphone, microphone and transmitter system in the headphone in planes produce sound wave. Yang ni kita guna dalam dekat plane lah, pilot. Produce sound wave that cause destructive interference with the surrounding noise. Kita guna semua destruktif saja. Kita tak nak konstruktif dia berlaku. Kalau konstruktif nanti pekak dia. Jadi kita dijadikan soft sound. We cancel the noise. Okay. These are some of the application of interference of wave that we use in our daily life. Dah faham yang ni?
Dah.
Okay. Then let's move on to today's topic. Today's I post one, the final subtopic. Wait, let me post. Okay. (5.7) Electromagnetic wave. Okay, dia tambah benda-benda ni semualah dalam syllabus kamu. Okay, last time dia tak ada. History of early scientific discovery regarding the electromagnetic wave. Okay, mula-mula Thomas Young. This is the one lah, Young double slit. Thomas Young show that light is a wave through experiment on interference of light. Nama eksperimen tu famous sampai dipanggil Young's double slit experiment. Okay. Lepas tu, tentu 1801 lah. Lepas 60 tahun. James Maxwell put forth the theory that light is an electromagnetic wave. Dia kembangkan teori bahawa light is an electromagnetic wave. Lepas tu, lepas 20 tahun, Heinrich Hertz generated a different kind of electromagnetic wave, that is radio wave. Okay, dia dapat generate the radio wave. Then early 20th century, kita ada electromagnetic wave yang terdiri daripada gamma, X-ray, ultraviolet, visible light, infrared, microwave, radio wave. Jadi ada cara kita nak hafal benda ni. Ini kena let me drink water. Kita ada radio wave, microwave, infrared, visible, ultraviolet, X-ray, gamma. Okay, kita guna formula Raja Melaka. This one I already teach you in form 3 ya. Raja Melaka ingin lauk udang tak goreng. Kena pakai baru dia akan hafal untuk kita. Okay. Lauk ingin Melaka Raja. Raja tu radio wave, microwave, and then infrared. Lepas tu kita ada light. Lepas tu kita ada ultraviolet. Lepas tu kita ada X-ray. Lepas tu kita ada gamma. Catat ni dulu.
Okay, sir.
Okay. இது பேர் நம்ம electromagnetic spectrum சொல்லுவோம். When you watch television, listen to radio, cook something in microwave, you are using electromagnetic wave. Electromagnetic wave produced when electric and magnetic field vibrate at right angle. That means 90 degree to each other. The direction of propagation of wave is perpendicular to both field. Maksudnya, kalau magnetic field dia bergerak horizontal, electric field dia akan bergerak vertical. 90 degree to each other. Okay. Magnetic field, electric field. Okay, kita boleh nampak the 90 degree dia. Macam tu. Okay. Right. Electromagnetic wave consists of series of whose frequency and wavelength extend over the broad range. Dia punya wavelength dengan frekuensi berbeza lah for a certain extent. Yang panjang. Okay, the electromagnetic spectrum is the range of frequency and wavelength over which electromagnetic waves are propagated. Wave in electromagnetic spectrum vary in size in terms of wavelength from very long radio wave and very very short gamma. Jadi kita akan tengok benda-benda ni rather than we see this. Okay. Kamu tengok. Ini dia. Okay, kita start daripada radio wave. Radio wave, lepas tu microwave. Infrared, visible light, ultraviolet, X-ray, gamma ray. Jadi, daripada radio wave, kita pergi susunan macam ni. Kita pergi susunan macam ni, kamu boleh nampak. Kita pergi susunan macam ni, dari left to right. The wavelength is decreasing. And the frequency getting increasing. Dia banyak. Jadi, kamu kena tahulah susunan yang kita susun tu. Raja Melaka ingin lauk udang tak goreng tu. Wavelength semakin menurun, frekuensi semakin meningkat. Radio wave, wavelength dia paling panjang. Gamma ray, wavelength dia paling pendek. Tetapi dari segi frekuensi, radio wave lowest frequency, gamma ray highest frequency. Contoh, ini analogi dia lah. Contoh, kalau radio wave ni macam building, human, tennis ball. Lepas tu, mana size tu? Contoh, kalau 1 meter, dia baru human. Kalau 10 power 2 ke 3 ke, itu dah height of the building. 10 power 3 macam semut. Dia bagi tahu light tu comparatively how long is that. We have a light very short like atomic nucleus. See that or not? Alright. So these are the spectrum. Kita kena tahu apa ciri-ciri dia. Properties of electromagnetic field. Energy is transferred by the wave. Most of the wave, mechanical wave, progressive wave, they transfer energy. Show characteristic of polarization. Polarization of wave, kamu tak belajar dalam silibus kamu, buang yang itu. Yang tu nanti kamu pergi matriculation, kamu belajar. The wave are electrically neutral. Yes. Tak ada charge. It undergo the same phenomena like reflection, refraction, diffraction, interference. It can travel through vacuum. So the wave speed is speed of light. Speed of light is 3 times 10 to the power of 8. Obey the equation C equal to F lambda. Kenapa kita cakap V equal to F lambda? Sebab V itu adalah constant untuk electromagnetic wave. Dia selalu gerak dalam speed of light. So kita ganti V dengan C. Velocity of the light. Okay, the magnetic and electric field component will oscillate at right angle to each other and to the direction of propagation also. Kalau dia cakap direction of propagation di 90 degree, itu bukti adalah transverse wave. Transverse wave. Dan elektrik dengan magnetic field dia selalu 90 darjah lah antara satu sama lain. Okay, the most important characteristic, it does not require a medium to propagate. That means it can propagate, travel in a vacuum. Can travel in a vacuum. Dan yang ke-8 adalah it is a transverse wave. Okay, ini ciri-ciri properties of electromagnetic wave. Okay, the last part. Habis ni kita boleh habis kelas lah. Okay, kita tengok. One minute. Right. Saya guna ni. Application and detrimental effect of the electromagnetic wave. Okay, kita tengok dia punya wavelength, source dia, application kat mana, and what is the danger. Okay, yang ini banyak nota saya tengok dia tak mention about the danger. Sebenarnya dia ada dalam silibus kita. Okay, kita kena tengok silibus tu betul-betul lah. Okay, contoh kamu tengok. Dia tak bagi directly to the textbook, but they give in the form of activity. Activity ini kena tengok betul-betul apa yang dia tanya, sebab yang itu part of the syllabus. Cannot ignore just like that. Okay, kamu boleh tengok. Okay, gather the following information. Okay, kejap. Saya kecilkan dulu sikit. Factors that cause overexposure to the electromagnetic that you have chosen. Potential harmful effect due to the exposure of the EM wave. Step needed to be taken to reduce the exposure. Maksudnya kita kena tahu apa danger exposure of EM kita. So I give you all the examples here. Okay, first thing, radio wave. Dia boleh jadi sampai 10,000 meter. 10,000. Kalau 40, 10,000 lah. 30, 1,000. 10,000. 40, 10,000. 10,000 sampai 0.1 meter. Okay, that much bigger longer your radio wave. But biasanya siapa yang dari mana radio wave ni wujud? Radio transmitter, lightning and also the star. Okay, kita baca satu persatu dulu. Untuk application dia, okay, mana kita gunakan radio? Nama pun dah radio wave, memanglah kita pakai dalam TV, radio, internet. Okay, baik, for broadcasting and wireless communication. Jadi dalam radio wave ni kita ada banyak wave dia. Ultra high frequency, very high frequency. Ultra high frequency kita gunakan untuk TV dengan mobile phone. Very high frequency kita guna untuk local radio and wireless telecommunication. Okay. And sometimes local TV and radio. Okay, sometimes wireless communication tadi kan. Baik, apa yang dimasukkan dengan wireless communication di sini adalah kamu punya Bluetooth. Wi-Fi. Kalau dekat luar negara, Zigbee. Z wave. Ini semua ada. Sekarang lagi ada apa ni, NFC. NFC. Yang tu semua wireless lah tu. Okay. Baik. Ya. Yeah. Ini yang biasa kita guna untuk radio wave. Dan danger dia adalah potential risk to health, causing migraine, headache. Kalau kita terlalu banyak guna handphone, kadang-kadang kita sakit kepala kan. Yang tu semua overexposure of radio wave. Okay. Next one. Microwave. Microwave, ingat satu bendanya kita guna untuk satellite. Okay. Radar transmitter, star and microwave oven can produce the microwave. Okay, kita guna untuk satellite transmission must. Kalau soalan tanya satellite, jangan jawab radio wave. It is a microwave. Walaupun microwave ni sebahagian daripada radio wave, tapi kita kena selalu cakap microwave sahaja. Okay, kita juga boleh gunakan untuk radar system, like navigation, weather forecast, traffic speed camera, global positioning system, GPS, kita guna microwave. Cooking, kita guna microwave. Okay. Nak tentukan di mana kapal terbang telah terjunam, telah terhempas. Yang tu kita guna radar system. And then we still use it for the Bluetooth, Wi-Fi, Zigbee, Z-Wave, NFC. Okay, the wireless communication as well. You can write there for wireless communication as well. Okay. Jadi apa danger dia? Okay, danger dia adalah internal heating of body tissue. Boleh berlaku pemanasan dalam sel badan kita lah. Tisu lah. And also can cause cataract. Overexposure. Okay. Next one is the infrared. Yang color warna merah. Infrared kita dapat dari hot object, sub and the flame. Okay, contoh kita boleh guna untuk apa? Okay, kita tengok. Infrared kita guna untuk night vision. Night vision binocular, night vision camera, like that. And then we use for thermal imaging. Contoh dalam movie semua kita boleh nampak. Kalau ada alien, dia boleh nampak dia punya bentuk dia warna merah macam tu. Remote control, obviously. Burglar alarm system. Dekat company semua kamu pergi, ada warna merah, dia pusing-pusing macam itu infrared. Auto focusing camera. Data transmission through optical fiber network. Internet lah, kita transfer kita punya data. Okay, lepas tu kamu boleh tambah ni dari textbook drying paint on a cup. Kita guna infrared. Kenapa kita guna benda macam ni? Sebab dia dari benda yang panas kan. Jadi semua ni panas. Dia drying paint on car. And then sometimes we can use for cooking as well. We can use infrared for cooking. Kita ada cooker all semua. Kamu boleh tengok oven, grill, toaster. Kamu boleh tambah. Okay. Jadi kalau overexposure, obviously overheat and screen burn. Okay. The first three. Okay. And then the next three. Next four lah. One shot. Visible light. Light yang kita normal tengok tu. Tujuh warna dia. Merah jingga. Okay. Michael Jackson kenal lah balik India Utara lah. Okay. Yang tu kita terhasil daripada sun. Mainly. Very hot object. Bulb. Fire. Okay. Why we use the visible light? For vision. For us to see. Photography. Photosynthesis. Photocell. Okay. Kalau kita overexposure of light, skin cancer, damage to retina, increase the rate of premature skin aging. Cepat tua lah. Okay. So that's a normal light. Ultraviolet, white hot object, example mercury lamp, UV lamp, also your sun, where you can get UV. Lampu panda floor dulu-dulu memang dia ada ultra. Okay. The main thing, ultraviolet, detection of the fake banknote atau kita panggil counterfeit money, duit palsu. Okay. Sterilization, drinking water and medical equipment, kita guna UV ray. Alright. Lepas tu, production of vitamin D in human body, production of fluorescent effect. Okay. Lagi kita boleh guna untuk purification of water. Kalau apa ni, water dalam aquarium tu, kita kadang-kadang dia guna UV punya filter juga. Okay. Purification of water. Dia boleh bunuh mikroorganisma. Okay. And also, this is included in your textbook. It also behave like as a insect trap. Perangkap serangga. Tak tahu, tak pasti macam mana dia buat. Okay. So, kalau UV dia banyak, skin cancer dengan cataract mesti ada punya. Tambah cataract. That's why the ozone layer protecting us from this harmful UV ray. Kita pula pergi pakai CFC punya barang, bagi ozon dia penipis. Okay, the most important one, X-ray. X-ray dari X-ray tube ataupun daripada star, kita guna untuk radioterapi. Okay, kita guna untuk medical imaging, untuk dapat X-ray photograph lah, nak tahu detect fracture or broken bones. Airport security check, the luggage they will check, right? The one all X-ray. Ini kena ingat, dia selalu tanya yang ni. I mean, detection of cracks in building structure. Okay, yes. And then also for the want to check authenticity in painting. Adakah painting ni rekaan atau original? Dia gabung dari mana-mana atau tidak? Kita guna X-ray juga. Okay, X-ray obviously cancer cell damage because it is a ionizing radiation. Yang ni adalah ionizing radiation. Seterusnya gamma ray daripada radioactive substance, cosmic rays. Contoh star. Okay. Radioterapi, kita gunakan gamma ray untuk radioterapi for cancer treatment. Kill cancer cell lah. And then sterilization in food and medical equipment, kita guna gamma ray. Kita bunuh mikroorganisma dalam food, dalam medical equipment. Also in a pest control in agriculture by making the male pest infertile and also kill the beetles, for example lah. Okay. Gamma ray ni dia very dangerous because have the highest penetration power. So dia boleh menyebabkan DNA mutation which develop into cancer and also cell damage. Dia boleh digunakan untuk buat treatment cancer at the same time causing cancer. Okay. Kalau radioterapi dia akan target satu sel saja. Contoh, sel tu saja dia akan mati. Sel lain semua dia akan tak akan efek lah. Tapi kalau dia expose banyak macam kamu tak tahu, dia akan jadi DNA mutation dan menyebabkan cancer. Jadi dia boleh jadi penyakit, dia juga boleh menjadi ubat. Jadi kita kena tahu gunalah gamma ray ni. Baik. Boleh faham?
Boleh, sir.
Okay, then we finish our chapter 5 ready. I think kamu buat dulu 5.7 kat rumah. Nanti 5.6 punya exercise kalau ada saya nanti send to your WhatsApp. You try all this question because wave yang dia selalu tanya banyak. Dia ada banyak benda yang kita kena cover dekat wave. Lepas
Yes,
tu
sir.
mungkin Ahad ni kita akan bincang. Mungkin minggu depan baru masuk chapter 6 lah. Okay? Right.
Yes, sir.
Alright. See you. Take care.